Hello, my name is Manny,
I'm Sophia.
I'm Megan.
And my name is Malaysia.
and today we'll be discussing what color is silver. And before we start discussing the color of silver, we need to understand what are nanoparticles. Nanoparticles are small particles that are undetectable to the human eye that are 1 to 100 nanometers in length. Its properties vary from its physical and chemical characteristics compared to its larger material counterpart. This is dependent due to its shape, size, and surface area. Some real-world examples include targeted drug delivery, UV blocking in sunscreen, and imaging in medicine.
This diagram shows the particle level process of how silver nanoparticles are synthesized in our experiment. The reagents include silver nitrate, sodium borohydride, so in the first picture, silver nitrate dissolves in water and separates into silver ions and nitrite ions. At this stage, the Ag plus ions are evenly dispersed throughout the solution. In the second picture, sodium borohydride acts as a reducing agent. It donates electrons to the silver ions, converting Ag plus into neutral silver atoms. This is the reaction that begins the formation of solid silver particles. And the third picture is nucleation. So after silver atoms form, they begin sticking together to create small clusters called nuclei. These tiny clusters serve as starting points for nanoparticle formation. In the fourth picture, it's growing, so as more silver atoms attach, the clusters grow into nanoparticles. So hydrogen peroxide acts as an oxidizing agent and removes atoms from unstable surfaces, which helps control the shape and size of the particles. In the fifth picture, sodium bromide and sodium citrate are acting as capping agents. So bromide ions help control the size of the nanoparticles, while citrate stabilizes the surface and prevents the particles from sticking together and forming bulk silver. Lastly, in the last picture, different nanoparticle sizes absorb different wavelengths of light due to the surface plasmon resonance. This causes the solutions to appear in different colors, which we measured using a spectrophometer.
On this slide, we're going to talk about our hypothesis. Our hypothesis is that changing the amount of reagents would change the physical properties of the nanoparticles. We expect the attributes like size and color of the nanoparticles to change. This is because the concentration of reagents affects how fast the nanoparticles form and how large the nanoparticles grow. For our experimental plan, we keep the amount of silver nitrate, and sodium borohydride the same for each trial. Then we vary the amounts of sodium citrate, sodium bromide, and hydrogen peroxide in each trial. These chemicals control how the silver nanoparticles grow and how the silver nanoparticles stabilize, which changes their size. Since nanoparticle size affects how the light interacts with them, we expect the color and absorption spectra to change depending on the reagent amount. By comparing the colors in the absorption maximum values of different solutions, we can determine whether our hypothesis about reagent quantities affecting nanoparticle properties is supported. Here in our table, we have the different trials we're doing, including the control trial, how the silver nitrate and the sodium borohydride volume both stay consistent throughout each trial, and the hydrogen peroxide and the sodium bromide values are the ones that are going to change. And here in the last category, we have our expected color change for each trial.
So for the expected data, what's going to look like when we actually do the experiment is that we will collect the qualitative and quantitative data. So first off, the qualitative data that we will collect includes the observed color of each solution in different trials. The quantitative data will be the absorbance at different wavelengths. And if our hypothesis were to be true, the amounts of sodium nitrite, sodium bromide, and hydrogen peroxide will change, which will affect the nanoparticle growth. And as a result, we will see consistent color changes between trials and shifts in the absorbance peaks in the spectra, which will indicate differences in nanoparticle sizes.
And that will conclude our presentation on what color is silver. Thank you for listening.
Thank you.
Thank you.
Thank you.